Hello, everyone. Thank you so much for coming. I see many familiar faces. Thank you. My name is Andrew Sakowicz. This is my colleague, friend Pizzi. We work in Esri Professional Services. Today, we want to tell you about our experience, our practice, the tools, use cases, and we will focus, of course, on ArcGIS Enterprise performance and scalability best practices. So here's our agenda. We'll start with a quick overview, what is ArcGIS Enterprise and why it's so challenging to monitor that. We'll cover quickly site design, the main consideration, performance concepts, how do we handle horizontal scaling, workload separation, how we do capacity planning, sizing, testing, finally performance, and our main focus, monitoring ArcGIS Enterprise. We finish this with the real use cases, the things that we have seen in the field, and finally we'll tell you where you can download and try these tools. So we have a busy session. Both of us, Frank and I, were at the ArcGIS Server Showcase Performance and Scalability. For those of you who will not have a chance to speak to us at the end of the session, we are available today and tomorrow. So hopefully we'll have a chance to speak, all of you who have follow-up questions. So I will just dive in. So what is ArcGIS Enterprise? Well, these are the main components: web adapter, portal, ArcGIS server, data store. But this session is not about covering the architecture, all the components. It's for you just looking at this diagram, and if you're in charge of monitoring, making sure that this is 24/7 solution, you have lots of components to monitor. What would be the best way to bring the site down? Just maybe, sabotage the load balancer, yes? Or misconfigure load balancer. Actually, I was talking to somebody, one of the users, and he said like, oh, I configure portal HA by a misconfigured load balancer. And of course, there's only one site was working, and when something happened, it fell over to the other site and didn't work. So don't try to understand this. It's just more for us to understand. There are a lot of components: ArcGIS server, data store, files, config store, load balancers, and how do we handle this? Let's start first about some consideration when we have workload separation. So usually we start with our ArcGIS server one site, but then when we have visualizations and data management and imagery and maybe big data and others, ideally we want to separate this into separate sites. So this is our best practices. Now the challenge comes when, what's practical? So if I have one map service, one image service, and one geoprocessing, should I have 3 sites? That's probably not the good reason to separate this. But we need to discuss this, what's the best way to separate. If you choose to have them together, what are the not recommended combination or perhaps strongly discouraged? So be very careful combining image server with others, or geo event with other servers, or geo analytics. The reason for that is that these are resource intensive servers, so they might starve your other mission critical map services. So just be careful how you do this. If we want to scale the horizontally, well, before we add these machines, we need to understand the size of these machines, so we need to conduct the capacity planning. Now, what are the interesting considerations? You definitely should be aware of, if you have any spatial analysis or insight, these are very resource-intensive operations, so you might need to add additional machine. ArcGIS server site design, administration, and consideration. So we have many options. We have site, we have silo, site, and clusters. Silo offers a lot of horizontal scalability and redundancy. The challenge is to synchronizing, but it's a really good architecture. But we really need you to start migrating into this side, because if we want to federate with the portal. This is the recommended architecture. So right here, the challenges are we need to design shared storage, and we need to make sure that all the communication between these nodes are available. Also, there is a cluster. How many of you have sites with not default cluster? You have named clusters. Okay, all right, so that's good. It's a small percentage because, you know, eventually we will be deprecating this and we will replace the clusters with a dedicated site. So it's just a quick intro to the components, ArcGIS Server. What are the things that we need to watch out for when we design the ArcGIS Server? Well, we need to make sure that we provide sufficient infrastructure resources. What is the number one? Well, number one, in my opinion, is CPU, because CPU is a typical engine of all the applications, so we need to make sure that we have enough CPU. And of course, RAM, if you have many services. How many of you have more than 100 services? Okay. How many of you have more than 200 services? Yes, so I'm sure you know what I'm talking about, yes? Then when you have 200 services, you need to start thinking about the memory. You typically run out of 16 gigs very quickly, even 32 gigs. So that it's a memory bound. NAS stability for shared config store. How many of you have lost connection to the config store? Okay. I mean, that was not painful. Yes, there was sudden death. There was just suddenly, nothing works. So it's very critical. Those of you who are configuring a portal HA, you need to make sure that this shared content is available all the time. And finally, network. When we have a site with multiple nodes, we need to talk to these nodes all the time. So it's very important that we have these resources. And we'll talk about other resources like VM later. What are the best practices? So for those of you who raised your hand with 200 services, how do you manage the memory? You need to identify unused services. Now, if you have few services, you just look at the manager and you see them. But if you have 200 and they're being used sporadically over the time, you need tools to identify what are the services have not been used in the past 2 weeks or past month. And we will show you these tools. Tune slow services. You know, why is so important? I use the analogy of the heating bill. If you have a high cost of heating bill, the first thing I would look at is, do I have broken windows? Yes? And that's tuning. So if something is slow, it will consume, not only they will impact user performance, they will not be happy, but it will also impact your resource utilization. So you want to tune that. The best way to do this is provide the best practices to your publishers. How many of you have an arrangement where services are being published by one department and you're in charge of managing these services, but you don't really have control? Okay, so I have few hands. So I empathize with you because it's a challenge, yes? Because, you know, and oftentimes if they are not GIS users, they might be a geophysicist, and they are just interested in using these services. They don't want to understand about scale dependency and symbology and number of instances. They just publish these things, and you are in charge of, you're receiving that. So if you have 200 of these bad services and only 16 gigs and 8 cores, how to deal with this? So these are the challenges. And you know, I'll show you the system monitor that we have seen these cases. We have seen these cases. All right, so if we, what is performance? So when we say performance, let's cover a few definitions. Performance is simply speed. So when you drive, how fast do you drive? When you render a map, is how many seconds did it take to render this map? It's a very simple concept. Performance is inherent to the user, not administrator. Users are the judge of the performance. Now, scalability, it's slightly different. If you're an admin, you're interested in scalability. How my system performs under load. Now, that's why we have a testing section as part of this discussion, because we can simulate the load and we can demonstrate how well or not system performs under the load. So that's the scalability. Well, every system has a capacity. So On the right side, clearly you wouldn't want to be in this traffic stuck in this traffic, but that doesn't mean that this is a bad design. There might be just too many cars that you have not anticipated. Or maybe you anticipated that you designed a system like elevators. So I oftentimes recommend to our users, do not try to predict the future load perfectly. Just agree on design targets, like an elevator. This elevator will support 15 users. Amen. That's what we have. And if it's more, we need to handle that. So this approach is helpful if we don't really have a clear target capacity. What would be the typical example? If you have external applications that serves the entire US, how many concurrent users should you use? 300 million, 1 million? It's challenging. So oftentimes we say, okay, this is our best judgment. We're designing this for 100 maps per second. And after that, we need to react. Bottlenecks are a little bit more interesting, So all of you should be able to detect capacity at the end of this session. This is easy. This is easy to identify and fix. The bottlenecks are a little bit more challenging because you have all these lanes, you have all these CPUs, but you only left, the toll booth could be your instances on ArcGIS Server. So what's the default number of instances when you publish a service? Yes, it's 2. How many concurrent cars can go through these 2 toll booths? 2. If you have 2,000 users, what will happen to 1,998 of them? They are standing and waiting. Now, if things are moving really fast, they might be waiting for 1 millisecond or 1 second. They will not even notice that there is a bottleneck. But if the service is slow and we apply more load, suddenly you might find yourself here. So it's a classic. Now, another challenge with this is that when you're admin and you log into the system and you look at a task manager, CPU, and memory, you say, everything is perfect. I do not understand why performance is so bad. Because everything is queued up before entering to ArcGIS Server and ArcGIS Server System. Yeah? So we will talk about this as well. Let's follow up with this freeway analogy and try to use it to understand how ArcGIS Enterprise performance will behave. So we have a freeway, and this is one car or one user. Maybe it's 4 a.m., and we are adding more users to the freeway, and the response time is increasing. And that's expected. Every system will behave that way. If you use the load testing, you can simulate that. We like the concept of the throughput, which is transactions per second. And you see at some point we'll level off. And this will allow us to identify capacity. But before we get to this, you see these things are user, yes? So how many users, how many maps per second, and what's the response time. But we can predict that looking at the system. So I look at the CPU utilization and network and memory, and I can determine that, well, this response time probably will be bad, and also help me to identify capacity. So when you look at the monitoring tools, you always need to wear 2 hats, user hat and the admin hat. And ultimately, user hat is more important. If users are happy, everything is good. Infrastructure resources, we can add or remove it as needed. So let's talk quickly about the process and tools. Over the years, we developed several tools. My first tool that I learned how the development was MXD PerfStat, because I just couldn't take the pain of just banging my head over these MXDs. I went to some of you, and some customers have thousands MXDs, and we need to tune these 1,000 MXDs. It simply is not practical to right-click and refresh these layers. We needed to have an automated tool to go through that. And that's how MXD was born, because I just couldn't take it anymore, spending hours. And that just took me on this journey of building with my colleagues more and more tools. All the tools are use case driven. Everything that is there is a story from a field. Somebody went, somebody experienced something, and we developed these tools. So system designer for capacity, system test, and system monitor. And we will talk about this. And these tools are kind of loosely connected, so they're not separate. To do the proper capacity, we need to have an input. Yes, we need to have an input from how many users, and also we need to have an input how expensive this operation is in terms of the memory and CPU. And then we plug it into the system designer, the capacity planning or architecture, and we calibrate this as more information is available. So it never stops. It always, always, always works like this. So, but tools are just tools. So they require the knowledge of the discipline and patterns and experience to use it effectively. And that's why you're here. The first step is infrastructure capacity planning, because it's one of the first things that you're asking us is, how much hardware do I need to budget for? And you know, we typically approach this by defining CPU, memory, and disk. As I mentioned, memory is memory bound when there are a high number of services, disk when we have synchronization or image, network if we have remote users. And I want to pause on virtualization. So I have a virtualization can have 30% overhead. And this is really awesome. If your VM has 30% overhead, that's really good news. But don't assume that it's less than that. It would be unlikely that the overhead is less than 30%. It is technically possible, but probably financially doesn't make sense because we need to consolidate of this. So 30% is something that I use for capacity planning. Is it possible to over-allocate VM and have an overhead of 200% or 500%? Yes. And I hope you're not one of them. But how do we know? And we'll talk about this. How can we quickly identify that your over-allocation is not excessive? So we use these tools to gather the requirements, and we produce diagram and capacity, mainly CPU, network, and memory. And we give you this report, and now you have a shopping list, and you can go and purchase the hardware. Quickly, performance testing. I mentioned is very important because that's the only empirical way to we can determine this. But before we go into performance testing, we need to make sure the system is tuned optimal. So how do we do this? Well, where do we start? Do we start at the bottom, the middle, or at the top? You know, if you're ArcGIS Server, you probably will start with ArcGIS Server because that's the only access you have. But we really need to start at the top. So we need to reproduce this. And we need to profile each request. We use Fiddler or other debugging. And we identify slow responses, or in that case, I have one. It takes 5 seconds. I found my slow response. I narrowed down from a big application to one map service. And as you see, you know, when I look at this URL, I recognize it's an ArcGIS Server map service. So it's really good. Now, before jumping into further tuning, I always want to know what has happened in the past. What is the history behind that? So we can use ArcGIS Server Statistics just to see how prevalent, how frequent the problems were with the services. So ArcGIS Server Statistics, we can use system log parser to parse logs, or we can use the system monitor. And we cover these tools more and more. So now we went to the past and we say, okay, we got it. You know, this is the smoking gun. We really need to figure out how to tune this. So what's next when we have this slow map service? Where do we go next? Behind the map service is MXD. How many of you have used MXD PerfStat? Very well, thank you. So it's very simple to run, and it can point you exactly which layer is slow. Notice how quickly we narrowed down our search. We had a big application. Now we're at the layer level, which is actually Oracle table. So, and we can stop there. And if each of you get to this point, that would be very impressive, and it would help us immensely to help you with the performance. But not everybody is Oracle DBA, and you might say, I am done here, I am passing this to somebody else. But for those of you who are familiar with these tools, by all means, run Oracle Trace, identify the response time, and even though now we've proven that it's Oracle, why we've proven that it's database? Because the response time is 4.7 seconds, and database CPU is 4.7. So you see, clearly, it's at the database level. Now, when you look at this, it makes our diagnose easier. We don't have to look at the network. We don't have to look at anything else. It's at the database level. But what's at the database? Well, we reproduce this, but we still are not understanding why this is so slow. And when we run the execution plan, we notice that spatial index is not being used. This is not for you to learn how to do Oracle trace and analysis. This is more to understand the level of effort and all the layers of tuning that are required. So when we do performance testing, we start with the hardware, because hardware, as I mentioned, virtualization or different chips might have a different performance footprint. And then we immediately go into GIS services, and after that we test application. Because this is very easy for us to test. Testing application is a little bit more challenging. Plus, we need to have the application available. So application is available oftentimes at the end. But these engines are available earlier, and we should do this. And again, you can download our tool and just quickly learn mechanics, and you can be a tester. But what if you get bad numbers? The results are bad. What do you do with this? Well, you need to have a knowledge of tuning and configuration, and that's why this comes with the experience. What am I saying? That you should not be testing? No, I recommend all of you download this testing tool and test, and look at the numbers. And that will be the first step. And if you're able to troubleshoot or the numbers are good, you validated your environment. If not, try to find people who can help you with this. What tools do we offer? We have used many tools, Visual Studio, JMeter, but we developed our own system test tool because it's GIS aware of. And when we go on site, we don't have time to writing scripts and for loops and B boxes. We want things to be available to us very quickly. So with this tool, it's aware of all these services that are very easy to test. And also you can test application by recording this in Fiddler or other tools and producing the HAR file and implementing. And here's the matrix comparison. They're all really good. It really depends on what are you trying to do. One thing that you might consider, if you're using other tools, you can still use system tests to produce the data as an input to other tools. And many of our customers are doing this. All these slides will be available, so I hope that you will have a time to opportunity to analyze that. But this presentation is about our experience and our tools, and we're familiar with this, and we're very effective with that. It does not mean that we're promoting one tool versus others. Why are we testing? To identify bottlenecks, to prove the capacity, and to demonstrate the performance SLA. So, and here's the screenshot. I'd be happy to demo to you later if you stop at the ArcGIS server site. But it's very easy. When I say GIS aware of, you see that we have a map, and we're actually zooming in. Think about this. If you're using JMeter and there is no map, and you just wrote the algorithm to generate the B-boxes, and you're hitting the Pacific Ocean with no data, I mean, the results will be very impressive. I'm sure you can figure this out. I'm sure you can, exclude where something, but we want things to be affordable, to make it fast and painless. We don't want to get a handle and a piece of metal and build hammers so we can use it to nail. And these are our ready-to-use hammers. Help is pretty good, and I encourage you to download and play with this. All right, so I think we're doing okay on time. Monitoring ArcGIS Enterprise. What are the challenges? So this is my stories from the field. When I go to the customer side, and oftentimes it's the same thing. It's a round table of admins, network admin, DBA, storage, GIS admin, managers, and we are discussing how to troubleshoot the system. And we go around the table, so do you see anything in the database? No, I'm good. Network, no, fine. Storage, no, fine. And we finish the going over, and everybody's okay, except the problem is still there. And we, in professional services, we have 3 days to fix the problem, or 5 days if we have a generous scope. So the time is, so that's a challenge. When we ask for the data, we get different tools, different formats. It's hard for us to correlate. I feel for all of you GIS admin that you're in charge of systems like a version geodatabase in Oracle without access to Oracle. And I know that oftentimes you don't have access because when I get on site. So we need this type of mechanism to overcome these challenges, to empower GIS admin to give us data that we can translate into actionable information and make decisions 3 days later. So how do we do this? Well, there are many, many excellent tools. And we recommend that you use our tools as part of coexisting or use as a reference implementation. You can customize your tools, but be aware of that. It could be challenging. So you need knowledge, expertise in designing these effective queries and dashboard. I say, there are many, many excellent tools parsing logs, but it's like SQL Plus, like somebody gives you SQL Plus and say, if you know the query syntax, you can have any report you want, but you need to know the query, and that's to know the query that takes 15 years experience of farming in the GIS land, and you have this dirt under your nails. I mean, that's what it takes to do that. SQL Plus is not enough. So just, if you are evaluating tool, because we have gone through this, and we have put together the list of attributes, the features. If you're evaluating the tool, these are some ideas that then you can use. I noticed that I'm not even highlighting scalability and end-to-end. I actually highlighted statistics. We like this very much because it allows us to quickly parse a lot of data without graphical implementation. So let's say if I see this, I know max is very high and P99 is very low. It's a spike. I don't need this chart. All I need is statistics. Now you might say, well, why do I need to watch the statistic? I can look at the chart. But sometimes we need to analyze past month. The most challenging case is when you say, sometimes it works, sometimes it doesn't work. And we had a problem like 3 weeks ago. So what do I need to do? I need to generate report for the past 3 weeks, for the past month. And then I spot that, well, you know what? You're right. It was one occurrence when something was bad. And it's actually excellent news because it was one time. I don't know what happened, but it was one time. So maybe we can live with this. Now, on the other hand, if the width of the spike is very wide, maybe 10 minutes, then the impact of that will be very different, yes? Is everybody following me? The width of the spike is the critical factor. If it's 1 second and impacted only 2 users per month out of 1,000, maybe it's not a big deal. How about that? We oftentimes use averages, and I say, well, be careful about the averages because if you stick your head into a freezer and your feet into oven, on average, you should feel comfortable. Then a customer says, something is wrong with your tool because min should never be equal to max. And I say, yes, it is if sample is 1, yes? So the same with so we need to have this large sample to, I don't know if you guys have seen this live dentist commercial about monitoring. So what does it say? Why monitor a problem if you don't fix it? And that's my point. That the true measure of success of our tools is if we are able to fix real problems. Just because we have monitoring tools, it's not good enough for us, and that's how we measure this. I wanted to play this video for you, but I couldn't get the permission. So. Click it, it's hilarious if you have not seen it. So what else do we have it? Our key approach is end-to-end and continuous. That's really the premise. We monitor everything. Why? Because the problems are not happening just at the ArcGIS server tier. Actually, most of the problems that I have been involved, and Frank recently, ArcGIS server is not a culprit. ArcGIS server is a victim of we lost access to the config store, yes? I mean, maybe we can recover more gracefully from this lost connection, but nevertheless, it's an issue of lost connection to a disk or another machine. So, analyze configuration, but it's not only operational. Think about the usage trends, performance, and uptime. The key is having the actionable information. I mentioned this to you already, that there are many tools that it can give you a lot of data. And the more data you have, it's more challenging to actually act on that. So we need to have the right reports. The reports are for admins. If you're admin, you most likely are interested what's happening now, or maybe what has happened in the past day. But if you're a manager, you want to know, can you give me just the average statistic for the past month, and I want to analyze. And when you have these reports ready to use. There are many benefits to monitoring. And the one I listed there, highlighted, is empowering new GIS admins. I hope that you use this presentation to understand, to go back and say, these are the tools, this is the access that I need, because these guys who have done it for 15 years, they have learned and we need that. And this, in turn, will reduce our administration cost, will improve user performance, reduce the number of incidents, and many, many others. So if you need me to convince you more on that, stop by at the island. ArcGIS Enterprise use cases. So now, okay, nice theory, nice speech. Now show me the real use cases. Okay, so there was a problem. It's one of the reports, Excel. This is the response time. Look at these numbers. 80 seconds, average, maximum, 300 seconds. Clearly, terrible situation. There's something really terribly going on the system. But then when I look at the time, it's only on Saturday at 3 a.m. Okay, so it's not so bad, because there was some maintenance, something was going on. And even though if you look at just the numbers of response time, you might say, we have a major, major problem. But in that case, actually, yeah, maybe you were restarting site, or maybe that's the time of recycle. So we need this type of information. When we look at the monitoring tools, if you are doing this disconnected, you're just going to your IT and they say, wow, there's something strange with your server because every time at this time we see the CPU utilization. When you put this together, well, this is the time when we restarted ArcGIS server site with 200 services. I bet that exactly looks like this. There's nothing wrong with the system. That's what it takes to restart ArcGIS server. Let's not overreact because that's expected. Make sense? So we need to have this knowledge. We need to have a holistic analysis of everything. Otherwise, we'll react. Otherwise, we might convince ourselves we need to add more CPU or we need to add more servers. And it's not necessary. It's just expected. And we can look at the monitoring ArcGIS server process. And indeed, it's all related to ArcSoc. Now, what other process could cause that? What else is running occasionally at the time when we really we need the system to be available? Antivirus, yes? So you can have McAfee or other tools, and they just start scanning this, and bam, you have the spike. And we need to understand that. If you have a cache tiles or big folders with many, many files, and you do not exclude, you forget to exclude, or your IT forgot to exclude this, you will have exactly the same thing. At some point, the system will be unusable because we're doing all the scanning. What else you don't have in tools that are not GIS we're aware of? Monitor memory and ArcGIS instances. So what do I have here? These are the free instances. By default, we have 2 tollbooths, yes, 2. And then we went to 0. And if you are saying at that hour, users started complaining about the performance. I say we solved the mystery. We just need to hire more clerks to the toll booths because we have only two toll booths. And we can go and see other statistics showing increased load on the system. But this is just to double check our hypothesis. It's already here. It's telling us we need more instances. Monitor memory. So here is something where it says increase min and max instances because you see the maximum instances are 4 and the busy instances are 4. So it's just another view. It's an Excel view of showing us we run out of instances. We need more instances. And here's the bottleneck. These are the instances that I was talking about. How to monitor the network. I have my two best friends when it comes to monitoring ArcGIS Enterprise is Sample Word City Service and my 1 meg file. And I do a lot of things with these two things. Because if I need to get involved with the complex application that you have running, it's complicated. But this is isolated. So if ArcGIS Server Sample Word City is running and performing well, is ArcGIS Server working? Chances are yes, it's working. How about if I want to monitor maybe different network paths between web adapter or going through IIS or going through port 6080, I want to have a quick way of validating that there's some network bottlenecks. I can put these files in IIS, put them in ArcGIS Server, and just quickly download them from all these locations and compare, and it will give me maybe something like that. So here is a chart showing a network performance. And it doesn't matter the absolute value, but it's clearly that there are some spikes. Something is going on this. And that's how I start conversation with the IT. So remember the one round table when nobody had a problem? I go, I install tool, I analyze, collect the data, and we have another meeting, and then I ask, well, can you just help me understand? And another beauty of this is that this is not even GIS testing. This is just simple pinging or downloading the file. So I can give this test to the IT and say, you can do it yourself. You can get the same thing. And that's how we advanced our troubleshooting, because it's challenging. So what else do we have here? Well, what is your reaction when you see this? It's kind of symmetrical, yes? Humans don't work like that. That's another mystery that it's solved very quickly. It's just like you have a batch process running every hour. So every hour something will be slow on the system. I don't even know what it is, but I know it's a batch process. And they say, oh, I thought we removed this indexing of that. And some of you are smiling, you probably have heard that. So just looking the shape of that. Okay, so Frank developed the extension that not only helps us monitor the URLs, so response time at the server side, but also the network. And when you see the highlighted one we have is the network transport. So think about this, how do we do this? We send the request from System Monitor, and we measure time, how long did it take to process this at the server time, and total time, and we take the delta, and now we have this nice breakdown. So you see, do we have a network problem here? No, it's 0.001, so it's nothing. There's no network problem, but maybe it's a server. These are just examples. What another example I have is, oh, my favorite, VMware. So there is a concept of the virtual overallocation. What does it mean in simple things? If you buy one server and you virtualize this into 10 servers, that's what I mean. It's overallocation. Yes, there's no magic. You can't just have one physical server and turn it into 10 logical servers, virtual servers. You could, and there's nothing wrong with this, if only one server is used at the time. And you might say, well, that's exactly what our IT said. They analyze our patterns, and this is our concurrency of using this. And I say, fine. How about if the number is 100? Okay, the probability of too many users asking for this resource suddenly is going up. And what is the Murphy law? They will all ask for these resources when you need your server the most. And that will happen in Y sometimes is slow, Y sometimes is okay. So we try to quantify that. And a simple quantification is just how many VMs are running on this on the host, and also the ratio. But we want to monitor, we want to have access to the VM host, to the underlying physical machine, because that will help us understand these performance fluctuations. You cannot explain this just by looking at VM, because AI will say you have 4 CPUs, but they're actually not 4 CPUs. And I am sorry if you heard my joke about the ham sandwich, but Frank loves it and he cracks at this all the time, so I say it again. I lived in New York City and I loved the delis. I would always go, and get the ham sandwich. And the sandwich was so big I couldn't take a bite on that. Just lots of ham, And then I had this idea, visualization, image of what would be the deli like if they go VMware, virtualized? I mean, the ham would probably like 2 crackers and a little sliver of the ham, and they still would call it the ham sandwich. So the point is that that's exactly what it is. You bite this, and it has a label ham sandwich, but it's not the same ham. Okay, so we came up with this maturity model. There's nothing wrong with this. If you find yourself at a level 0, there's nothing wrong with this. But if you have mission-critical 24/7 solutions, you may want to evaluate, did I do the architecture? Did I do the testing? Did I do the monitoring? Do I analyze the system? Because if you're not doing this, then you are increasing your risk. Now, there's nothing wrong with having the risk, manage the risk, but it needs to be calculated risk management and not just so tools. This is the URL, and all of you're welcome to make a note of this. It's a public information, and this is a quick start, so you can open this. It will walk you through how to install System Monitor, our demo site. This is our catalog. Soon Frank will give demo all of it, so you can see. You may recall I mentioned MXD PerfStat. You can download. I quickly cover System Designer. We briefly mentioned a log parser and system test. So this is just one place where you can just go and get all these tools. And if you choose to try our System Monitor, this is the architecture that we have. So we are on the right side in the cloud, and you will download this lightweight desktop, and you will install it on your dedicated machine away from your production. Notice that this is production. Nothing is installed on the production. We monitor everything remotely and non-intrusive. That's very important. There are many monitoring tools that require you to put the agent on each machine, and they in turn takes. So you can have a proxy and you move the data. Play with this. If you have confidentiality concerns, they are valid. If you monitor ArcGIS Server, you will be sending us names of your map services. You will be sending us host names of your machines. And these are probably the only thing that I can think of that might be sensitive. But this is not, if not the issue, please use it. Of course, we have an on-premises version, but it's, you would have to integrate the other piece, and it's a little bit more. So I'm switching to Frank, and I did really well on time.
Just in time. Okay, just to give a quick recap on what Andrew brought up earlier with the architectural diagram. What we have here, what we're viewing here is a web server front end that has a data store that receives events that are configured by the desktop application that Andrew mentioned that you might download and try as a demo. And the result of this is once you install the desktop is you configure what it is you wish to monitor. We have some promoted counters that we're very interested in ArcGIS server systems and top level things that we think are the most important. And you'll see that through the tutorial. Once you've configured everything, then you wait for the data to build up and you begin to analyze the data, you begin to look at the data. So let's take a look at what might happen in a fictitious situation. What we're going to demo now is a worldwide solution, let's say London, Redlands, other places, and we're in charge of keeping track of it, making sure it's up, if there's any problems, quickly resolving them. So this demo is built up for London, New York, Redlands, Sao Paulo, and you can quickly identify there's a problem in one of them. And because we use a tree structure and built up, you can quickly see there's a problem in system, and there's a problem in a particular system, and we're running low on memory. So you can see, this is where you would go inside of this application to find out what's wrong. Is anything broken? Is anything not working? This helps us operationally to keep things going and to quickly identify the problem and then decide on what the potential solution is. If we're running out of memory, there isn't much we can do except for go back, look at if our services need to be reduced, or if we can acquire more memory, but we need to do some analysis. And inside of the data from ArcGIS Server, we can determine what the next steps are by evaluating the services, if indeed it's in ArcGIS Server. Each one of these items here in this particular case, we can see in systems we have CPU, memory, network, disk, all the big counters, all of the most important counters, and we've omitted lots of things that are not important because we have a lot of experience in testing, a lot of experience in knowing where the primary problems are. So in systems, we look for bottlenecks in CPU, memory, network, and disk. Those are the biggest things in a machine. There are, of course, other bottlenecks, but these are the primary bottlenecks that we observe often. Here we can also see that we track Amazon, we can track ArcGIS Server. Oftentimes, if you go on site, you might want to evaluate the configuration of the pooling instances. It's actually quite difficult inside a manager because you have to navigate back and forth and you're not sure, you can't see, you don't remember the settings. And if you set a standard, I want only maximum 2 or 6 per node, it's hard to keep track of, especially if you have ad hoc publishing processes. Inside of System Monitor, you can quickly list all of them. You can list the total, each service here. You'll see the min per node, max per node, and you can just scan down and sort. It's also available in Excel, which is a nicer format for meetings and discussion and understanding. But this type of view for quality assurance is actually very important to quickly understand why you're running out of memory, why are the services having a long time restarting. So this is just one use case in particular. There are also several important extensions that are built up. Andrew mentioned them earlier. The application validation, what is this? It's simple. HTTP checkpoints are your #1 line of defense. If I'm monitoring an HTTP endpoint that goes from the web server to ArcGIS Server to the database, that one URL can tell me that whole stack is up. So if you have that one check running all the time, that can be critical to help you have an early warning signal whether something's bad. So in general, the application validation extension allows you to select multiple HTTP checkpoints for a particular application and keeps track of them all together for you. Here's something Andrew wrote, the VM hosts. Basically, this is a very common problem where we overallocate VMware, and basically that's the ham sandwich he was talking about. And here, if you were able to get permissions and scan here, you'll be able to tell if the density on the virtual host is too heavy. And oftentimes you'll see that if you have variable performance. So I was on site at this one location, and everything was just, ArcGIS Manager was just completely slow. 5 minutes to just render ArcGIS Manager. And then the next minute it was perfect. It would just come straight in. And then performance would be gone. So what we had happening there were workflow collisions in the different VMs in the VM host. So these things are like a ghost. They come and they go. And so if you have variable performance, something like I just described, it's likely that your IT might need to move your ArcGIS server to a less dense or less occupied VM host.
So Frank, we focused a lot on operational data, something that administrators are interested, but do we have anything for managers, for technical managers? Something that it's not just CPUs.
Pouring chemicals. Yes, we do. A lot of things are important to keep things going operationally. This is good for admins, but managers want to know how much work is my system doing? How many geocodes did I do? How many maps did I serve? How many tiles did I serve? All of these things would be nice to quantify, and we've built up something that will do that. In this particular case, we have a map that's showing all of the IPs in a live system. Actually, it's our system monitor demo. It's showing around the world how many hits we're getting.
So who's hitting this website?
It looks like mostly the US.
But that's our demo, yes? So if each of you connect to this URL in 1 hour, we'll have
a lot from Palm Springs.
Dots. So we're monitoring ourselves, and these are actually coming from people who accessed our demo site. That's correct, yes?
Yes. In our case here, it's saying 14 unique IPs from different countries. And so that's how many visitors. But let's take a look at another map of interest. Here's a map of the United States, which gives you a breakdown of which states people are coming from. And there's a statistical table off to the side that tells you 68% are from California, 7% from Alabama. It's really nice information. All of this is also available in Excel. Excel can summarize months worth of data, and so your managers can say, well, I want a month-long report. They can see all the throughput that comes through. It categorizes it in tiles, map services, feature services, every option that we have. So there's a good deal of breakdown, a lot of information for managers, including total throughput from the GIS system. And also, as a note, for those of you who are serving people internally, we can track ArcGIS Server user domains and sum the domains up. So if you serve domain A and domain B and you want to get some numbers from those domains, you can do that, as long as people are signing in with their Windows authentication. A quick example of some other correlated reports here is the response times of our HTTP checkpoint. I selected these 3 queries into HTTP, and you can see some are lighter than others, but these are the variable performance, and every once in a while we get a little spike. It's nice to see these kinds of things over time so that you can see if you have consistent performance, because you're systematically sampling something. As Andrew mentioned before, we're doing this systematically, and we'll eventually catch these ghosts that come and go, and you'll see these big long spikes inside of the response times.
Frank, is this standard UI or?
Let's take a step back. The standard UI looks like this. It's our whether things are working or not, but oftentimes we want to put things together in a report. And what we're showing over here is a custom report that I built out. It's using the world stuff that we just looked at over here. I built up a series of things for our HTTP checkpoints. I built up these reports for systems, so I could do quality assurance across all my systems. Sometimes you might get 10 VMs allocated to you, and you might find out that some of the CPUs aren't the same, and you're wondering why performance is variable. Well, because you got CPUs over here that are slower than CPUs over here. You might have not all the memory allocated that you wanted. You want to QA that.
Why don't we take a look at the catalog one more time? So I hope that now it makes sense to you why we call this view a catalog, because it is just like our catalog. And the one that Frank is showing us is web app builder. It's not even ArcMap, it's just he built his own web from scratch. Now we have templates, so you don't have to actually learn all the HTML and Node and everything else. But this is the flexibility that we were talking. Build the right reports, actionable reports, because the catalog is just full of data. And it's useful, but there's no correlation.
Right, the catalog's useful to see if things are working. The reports are useful for information to get you understanding. An example would be something like this. Let's say that I wanted to see all of that's the statistical view. I want to see all the processing. This is just CPU across many machines. And I want to get used to understanding what the CPU pressure is on these machines. If I observe this for a few days, then I'll normalize my expectations. Oh, all my servers are around 20%, not a big deal. Okay, I'm great. So now, a few weeks later, all my servers are running at 100 or 80%. I actually know there's been a problem. I know that something has changed. And so it's always good to know the basic temperature of your system, CPU, memory, network, and disk. If you're familiar with this basic profile, which will change over time, then you will know when something extreme is happening. So these particular items are of importance. The systems for monitoring what's the resources in your application, processes for investigation, whether they're causing trouble on your system, ArcGIS Server for counting your throughput and understanding the configurations, Portal for understanding how much content you've generated on your own, and Amazon if you're using that.
I think we made our point. So we have 5 more minutes. Are we good? Do you want to demo something else? All right. So in that case, I am looking forward to your questions. Was it helpful? All right. Excellent, sir. Thank you. Thank you. Thank you.
I wasn't very clear if system monitoring is a service that you guys provide, or is it an application we can download, install?
So the question was, it was not clear whether the system monitor is a service, or it's a download, or a product, or it's a tool. There are some consideration, for this to become a product, but right now it's in a pre-release. It's available as on-premise, so you can download, and we can help you configure. You can use our cloud, so that's also available as a service. That's what it is. Did I answer your question?
Yeah, and then another question. I think MXD per set is no longer supported in the newer versions of. There was an extension for ArcMap or something. Will this still run with 10.5 or 10.4?
The question was, is MXD, would MXD run in 10.5? Yes, it would. Maybe there's some extension that it doesn't cover. That's possible, but yes. Any other questions? Yes. Are we going to build something similar for ArcGIS Pro? What do you mean, like a system monitor?
Sorry, for the MXD Pro stuff.
Well, I think we already have it as part of the ArcGIS Pro. There is a component to, yes, built in. Yes, our colleagues already did that. Anybody else have any questions? Will we monitor Azure? Yes, yes. We started working on that. So it will be soon, like weeks, not years.
Andrew,
All right.
you had a question.
Yes.
Not smart question, but
Not a smart question.
what's the harm for you to know our host names and map services?
Say again, please.
What is the harm from my organization if you know my host name, machines, and map service names? If I use the cloud tool?
Well, think about this. If you're a member of intelligence or defense.
Any bad form?
Well, no. What I'm saying is that just the name, or if you're in energy and you say Gulf of Mexico, the metadata could be not something that you want to share. Does it make sense? But if you're not in a defense or intelligence, I think that or proprietary commercial, you should be good. Yes.
This system monitor has nothing to do with the load test. If I'm doing the load test before the production.
So the question is system monitor related to the load test? Are these two different things? Yes, they are. So load test just simulates many users. And you can, and load test tool have their own monitoring tools for the duration of the load testing. But you can run this in parallel. Also, the load testing tools, they have a higher granularity, so we collect the data every few seconds. But in System Monitor, the granularity is 1 minute. So 1 minute, 5 minutes, or 15 minutes, because we do not want to impact of the system. And load test, you typically are not load testing your production system, so we can impact the production system. But we use System Monitor to monitor production system, so it has to be non-intrusive monitoring. And especially it's challenging, and I can go into details. If you have many services, we monitor one folder at a time, not to impact production system. Did I answer your question? Very well. Anybody else? Yes, sir.
Is it possible to get CPU or memory information at the service instance level?
Is it possible to get information at the CPU level? We have extensions now when we parse the command line from Task Manager, and we can do this. So we have this extension. But out of the box, we monitor process. So we give you the average per process name. So we can say, you're running 200 ArcSocs, and CPU utilization average is this, and some of that. But it doesn't do what you're asking. That's a different extension. But we need to be very careful. For those of you who are dealing with hundreds of services, we need to be careful not to be top user of your system. So that we need to strike a smart balance of how much do we actually need to monitor. Maybe a subset, maybe something that it's critical to your solution, but not everyone. Okay. I don't see hands. Hey, again, thank you so much. Please stop by. We're heading to the showcase, and we'll be more than happy to continue this conversation. And if not, I don't see you. Enjoy the rest of your conference. Have a good afternoon. Thanks.